So in today's video, we are going to go over questions from IBMATH AASL exams of the year 2022 and 2021. So the first question is from year 2022, November, paper 1, IBMATH AASL exam. So it says consider a circle with a diameter AB where A has coordinates of the 1, 4, 0 and B has coordinates -3, 2, -4, and we need to find the coordinates of the center of the circle. So we are going to construct a diagram first. So we have a circle like this, and we have a point A and point B, and these 2 points create as a diameter, okay, and point A has the coordinate of the 1, 4, 0. Point B has a coordinate of -3, 2 and -4. Question A, we need to find the coordinates of the center of the circle. So we need to find the center. So we need to find this coordinate x, y, and z. Okay, so since we know that the center of the circle is the midpoint of the diameter AB, the midpoint of the diameter AB, we are going to use the midpoint formula, which is m equals x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. This is in your formula booklet, right? So we can say 1 plus -3 divided by 2, 4 plus 2 divided by 2, 0 plus -4 divided by 2. Then we get -1, 3, -2, and this is the center of the circle. Question B, we need to find the radius of the circle. So actually this is the question A, I. So this is second part of the question A. So we need to find the radius of the circle. So we know diameter AB's coordinates, right? Point A and B. So what we need to do is we first have to calculate the diameter of AB, the length of the diameter of the AB, and we need to divide that by 2 to calculate the radius of the circle. Or we can calculate the distance from the center to the either point B or point A, right? Then we can also calculate the radius, okay? Because we just calculate the center, which is the midpoint of the diameter AB. So we can just calculate the distance between the center and point B, and this is equal to radius of this circle. Then we can say the center is -1, 3, and -2, and point B has coordinate of -3, 2, -4, and using this information is using the distance formula, where we need to do x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared and the square root to calculate the distance. So we have to do -3 minus 1 square plus 2 minus 3 square plus -4 minus minus 2 square. Then we get the distance of the square root 9. Then we get it equal to 3. Okay, then let's continue from the question number A. So now the circle forms the base of the right cone, whose vertex V has coordinates of -1, -1, 0. So the point B, vertex, has the coordinates of the -1, -1, 0. Okay, so now we need to find the exact volume of the cone. Okay, we know that the center of the base, which is the midpoint of the line AB, has the coordinates of the -1, 3, -2, which is the center of the circle, which is the base, right? So to find the exact volume of the cone, we need to use the volume of the cone formula from your formula booklet, which is 1/3 times pi r square, which is the base, times the height. Okay, you can find this formula from your formula booklet. Okay, so we first have to calculate the height. This is the only information that we are missing. So the height is between the vertex and the center. Okay, so what you're going to do is we're going to again use the distance formula to calculate the distance between the vertex and the center. So height is equal to the distance between the V and the center. So it is equal to -1 minus -1 square plus 3 minus -1 square plus -2 minus 0 square. So we get square root 20. Okay. Then using this information, we can calculate the volume of the cone. So V volume of the cone is equal to 1/3 times pi r squared. The r value we calculated from the question AII. So 3 square times the height that we just calculated, square root 20. So the answer is 3 pi times square root 20. Or you can leave it as 6 pi square root 5. So let's do second question of the day. So this question is from year 2022, November, IBMATH AA, SL, paper 1. So it says that let A be a constant where A is greater than 1, and we need to show that the left-hand side is equal to the right-hand side. Okay, so we first going to start with the left-hand side. I mean, left-hand side is more complicated, so it's better to simplify the left-hand side and make it equal to the right-hand side, right? So we're going to go a squared plus this equal to right-hand side, and we're going to expand that fraction part. So we get this, then we can say the a squared plus a to the power of 4 minus 2a squared plus 1 over 4. Then we're going to add these two terms together by multiplying the 4 over 4 to the first term. Then we get 4a squared plus a to the power of 4 minus 2a squared plus 1 over 4, right? Then we can simplify this further into a to the power of 4 plus 2a squared plus 1 over 4 equals, then we can simplify this part into the a squared plus 1 over 2 to to power 2, which is equal to the right hand side. So we have shown that the left hand side is equal to the right hand side. Then let's do the second part of this question. So we need to consider a right angle triangle with the side of the length a squared minus 1 over 2 and a squared plus 1 over 2. So this is the right angled triangle. So we know that the triangle has a shape like this, and it has a 90-degree angle here. Okay, we need to find the expression for the area of the triangle in terms of the a. Okay, so we have a side a squared minus 1 over 2 and a squared plus 1 over 2. So the first step is which side is what, right? But from the question A, we know that the a squared plus a squared minus 1 over 2 squared is equal to a squared plus 1 over 2. Okay, this is something we already proved from the question A. Then from this statement, we know that when we apply this statement into this right triangle, we know that this is very similar to a squared plus b squared equals c squared, which is the Pythagorean theorem. Okay, so we can say the a is one of your leg, and the b is a squared minus 1 over 2, and a squared plus 1 over 2 is your hypotenuse. Okay, then we need to find the expression for the area of the triangle in terms of the a. So we know that the area of the right triangle is same as 1 over 2 times base times height. So we can say 1 over 2 times a times a squared minus 1 over 2. Okay, and this is same as a times a squared minus 1 over 4, which is same as the a cubed minus a over 4. But I should say you can stop at this point because this is the simplest form of the answer. Okay, so the third question of the day is from year 2022, May IBMATH AASL exam, and this is the paper 1 question. So it says that consider f of x is equal to 4 sine x plus 2.5 and g of x is equal to 4 sine x minus 3 pi over 2 plus 2.5 plus q, where x is all real numbers and q is greater than 0. The graph of the g is obtained by the two transformations of the graph of the f. Question A, we need to describe these two transformations. So we need to describe how this function g of x has transformed from the function f of x, right? So the first thing, when you look at this, you can see that the 2.5, which is the translations, translation of whether it's going upward or downward, has translated to plus q, right? So we can say that, okay, so the first thing is the translation or the shift by q, and then it's a positive q, so it's upward. Okay, or you can say it's a positive vertical direction, right? So because the 2.5 is referring to the y changes, right? So we have added positive q there, so it's q upward and it's a positive vertical direction. And then the next transformation that you can see here is the transformation with the x values. Okay, so you can see that the function f of x has just sine x. However, g of x has x minus 3 pi over 2. So x minus 3 pi over 2 means x is 3 pi over 2. So positive value. So means this is a translation or the shift by 3 pi over 2 to the right because it's a positive, and it's a positive horizontal direction. Okay. The next question, the y-intercept of the graph of the g is at 0, r, and given then the g of x value is greater than or equal to 7, we need to find the smallest value of the y, value of the r, right? So we know that the f of x is equal to 4 times sine x plus 2.5. So we know that this is for sure. And then the 4 means if I draw the graph, let's just consider 4 sine x first. So if I draw the graph of this, okay, doesn't matter where it is located, we know that from the principal line to the minimum point or the maximum point has the distance of the 4, right? Since our principal line for this graph is 0, your minimum point is equal to minus 4, right? That means your minimum point and then this possible principal x is 2.5 and then this unknown q should be greater than or equal to 7. Okay, then from this we know that your q value needs to be greater than 8.5, right? Then substituting x equals 0 and the q value that is equals to 8.5 from the previous question, then we can find this unknown r, right? Then we know that, okay, g of 0 is equal to 4 times sine x minus 3 pi over 2 plus 2.5 plus 8.5, and that is equal to r. So we can say 4 times sine 0 minus 3 pi over 2 plus 2.5 plus 8.5, and then 4 times sine negative 3 pi over 2 plus 11 is equal to r, and the sine 3 pi over 2 is equal to 1, right? According to your unit circle. So we can say 4 times 1 plus 11 is equal to r, and is equal to 15. Okay, so let's do the first question. This question is from year 2022 May IBMATH AA essay exam paper 1. So paper 1 means no GDC, right? So it says that consider the function f of x equals to square root 3 sine x plus cosine x, where x value is greater than or equal to 0 or less than or equal to pi, and the g of x is equal to 2x, where x is all real number. So we need to first find the f of g of x, right? So we have a composite function. So f dot g x is same as f of g of x. Okay, so in order to solve this question, we need to substitute g of x into the f of x. So g of x is 2x. So now the x value of the f of x is g2x. So we can say square root sine. We can say square root 3 times sine 2x plus cosine 2x. And that's it for question A. And question B, we need to solve the equation f of g of x equals 2 cosine 2x. And then we need to solve for the x value. And x is between the 0 and the pi. So we can say the f of g of x is equal to 2 times cosine 2x. And from the question A, we know that f of g of x is also equals to square root 3 times sine 2x plus cosine 2x equals to 2 times cosine 2x. Okay, so we first going to start this question by simplifying it. We're going to move the cosine 2x to the other side. So we have a square root 3 times sine 2x equals to 2 times cosine 2x minus cosine 2x. Then we have square root 3 sine 2x and it is equal to cosine 2x. And now we're going to identify that hidden one that is multiplied into cosine 2x, so we can solve for the x. Okay, so by moving some of these terms around, I can now say sine 2x over cosine 2x is equal to 1 over square root 3. And 1 over square root 3 is same as square root 3 over 3, right? Don't forget that. And also don't forget that, like whenever you do this type of question, you like to get rid of the radicals in the denominator, right? And then we have a sine 2x over cosine 2x. So if we let 2x equals to a, we have sine a over cosine a equals to square root 3 over 3, right? Then this part is actually same as the tangent a, right? Then we can say the tangent a is equal to square root 3 over 3. And on the unit circle, there's only two ways that we can have tangent value equals to square root 3 over 3, which are the 30 degree or the pi over 6 or the 210 angle 210 degree or 7 pi over 6, right? So we can say that the a is either pi over 6 or 7 pi over 6. Means we can also say, since the a is equal to 2x is equal to pi over 6 or 2x is equal to 7 pi over 6, then we can calculate x value as pi over 12 or x value equals to 7 pi over 12. And both of these values are less than pi. And according to the question, we need to find the x values between 0 and the pi. So the answers are pi over 12 or 7 pi over 12. Two answers. Okay, so let's do the fifth question of the day. So this is the year 2022 May exam. Okay, this is paper 1 of the IBMATH AASL exam for time zone 2. So we need to find the least positive value of the x for which cosine x over 2 plus pi over 3 is equal to 1 over square root 2. So cosine x over 2 plus pi over 3 is equal to 1 over square root 2. We first need to make this equation simpler. So we're going to let x over 2 plus pi over 3 equals to theta. Okay, then we know that cosine theta is equal to 1 over square root 2. When the cosine theta is equal to 1 over square root 2 on a unit circle, it happens when we have angle pi over 4 or 45 degree, right? So we're going to say then when theta value is equal to pi over 4, okay, or we also get the 1 over square root 2. Also, when you have a fourth quadrant, we have a positive cosine value. So it's a 7 pi over 4 is also your next positive cosine value. Okay, don't forget that. So let's draw it like this. So 7 pi over 4 is your next positive cosine value. So we know that there are two possible answers, pi over 4 or 7 pi over 4. Okay, then let's start with when theta value is equal to pi over 4. So when theta value is equal to pi over 4, we know that theta is equal to x over 2 plus pi over square root 3 and is equal to pi over 4. Then we know that x over 2 is equal to pi over 4 minus pi over 3, which is equal to 3 pi over 12 minus 4 pi over 12. Then we can say x over 2 is equal to negative pi over 12 and x value is same as negative pi over 6 and is less than 0. So pi over 4 is rejected. Okay, then let's talk about the other case when theta value is equal to 7 pi over 4. Then in that case, we know that x over 2 plus pi over 3 is equal to theta and is equal to 7 pi over 4. Then we can solve for the x, which is x over 2 is equal to 7 pi over 4 minus pi over 3. Then this is equal to 21 pi over 12 minus 4 pi over 12 and is still equal to x over 2. Then x over 2 is equal to 17 pi over 12. Then x value is equal to 17 pi over 6 and this is greater than 0. So this is accepted. So your final answer for x is 17 pi over 6. So let's do the final question of the day. So we have a question from year 2021, November, paper 1 of the IBMATH AASL exam. So we need question A, we need to again show that the 2x minus 3 minus 6 over x minus 1 is equal to 2x squared minus 5x minus 3 over x minus 1. So you can see that the left hand side is much more complicated than right hand side. So we're going to simplify the left hand side. Okay, so we're going to first turn every single term in the left hand side into fraction form. Okay, so 2x times x minus 1 over x minus 1 minus 3 x minus 1 over x minus 1 minus 6 x minus 1 is equal to right hand side, right? So now all three terms on the left hand side has a fraction in fraction form. Then we can combine them all together as like this. Then the numerator gets let's get rid of the brackets. Then we get 2x squared minus 2x minus 3x plus 3 minus 6 over x minus 1. Then the left hand side gets simplified into 2x squared minus 5x minus 3 over x minus 1. And is equal to the right hand side. And we are done. So QED. Okay. Then question B, hence or otherwise, we need to solve the equation 2 sine 2 theta minus 3 minus 6 over sine 2 theta minus 1 equals to 0. So we're going to do exactly same thing as the question A, we're going to first change everything on the left hand side into fraction. Okay, so every single term in the left hand side into fraction form. So we get 2 sine 2 theta times sine 2 theta minus 1 over sine 2 theta minus 1 minus 3 sine 2 theta minus 1 over sine 2 theta minus 1 and minus 6 sine 2 theta minus 1 equals 0. So I have changed every single term on the left hand side into the fraction form. Then we can simplify this into 2 sine 2 theta sine 2 theta minus 1 minus 3 sine 2 theta minus 1 minus 6 over sine 2 theta minus 1 equals 0. Then after expanding everything, you get 2 sine squared 2 theta minus 2 sine 2 theta minus 3 sine 2 theta plus 3 minus 6 over sine 2 theta minus 1 equals 0. Then we get 2 sine square 2 theta minus 2 minus 5, we get minus 5, right? Minus 5 sine 2 theta minus 3 over sine 2 theta minus 1 equals 0. Then when we let sine 2 theta equals to x, then we can say 2 x squared minus 5x minus 3 over x equals 0. Then this is same as 2 x squared minus 5x minus 3 equals 0. Then we can factor this out. So 1x, 2x minus 3, 1. And we know that this can factor into x minus 3, 2x plus 1 equals 0. Then x is either 3 or minus 1 over 2. Okay. We can say sine 2 theta is equal to 3 or sine 2 theta and or sine 2 theta is equal to negative 1 over 2. But you know that sine 2 theta cannot be equal to 3. Then if we let x equals 2 theta, sine x is equal to negative 1 over 2, that means our x value is either 7 pi over 6 or 11 pi over 6, right? Then x value is 2 theta, so 2 theta is equal to 7 pi over 6 or 2 theta is equal to 11 pi over 6. Then theta value is either 7 pi over 12 or theta value is equal to 11 pi over 12, right? Then since this is between the 0 and the pi, right, we can say the answers are 7 pi over 12 and 11 pi over 12. So 2 answers. So we can say theta values are 7 pi over 12 and 11 pi over 12.